Let's put on some music. Hello, Earth. This is the third episode of Making Cell, a series of videos where I create a programming language and environment from scratch while filming myself. And that programming language and environment is called Cell. So you will not be able to hear the music. I put a great album in the background from Kraftwerk, is the name of the artist. And the name of the album is Tour de France. But I noticed yesterday that my previous video was banned in a few countries because of the music in the background, and I think that's pretty unfortunate. So if you want to listen along to the same music, I'll just post a link to the video in the notes, so you can also put this in the background if you want. So yeah, today we are going to continue where we left off yesterday. Yesterday we were deciding what to do first, really. So we already have the spine, which is the Organization of Digital Information Systems, this treatise. I won't bore you with it because we already covered it in the last two episodes. So now we actually have to get Cell to do something. So yesterday I was thinking, okay, we could do two things. We could try to go from JSON to fourdata, which is the format that Cell uses to represent data, or from fourdata to JSON, so we can interface with the outside world within the context of a web browser. The other one is to do some implementation of basic operations like summing two numbers. The thing is that both of them really require parsing. So I was thinking about this problem over the course of the day as a sort of a background process. And what I realized is that maybe we should not even start there. Maybe we should start with something even more basic, which is like be able to send messages, that is calls, to this cell that is coming up, we're bringing to life, and those calls being processed. And the two basic calls that I thought are basically get and set. So we can just put this in the fourdata notation. It would be like basic calls, get, and set. Actually, we'll do it the other way around, really, because set really counts before get. If you have a system that has nothing, you have nothing to get, right? So we can start by setting something. So I would think that there has to be some sort of interface, and by interface I don't mean graphical interface. By interface I mean like a way to communicate with Cell, so that Cell can receive like a simple message, something like set. We're going to set a path, like for example the quintessential example would be set foo to bar. So then let's say that before the call, foo didn't exist, let's say, and now foo points to bar. So before, let's see if we can actually write this in a using fourdata itself. So let's say before the call, there's nothing. So we could represent the entire state inside cell as nothing. Then we put the call itself, which would be set foo bar. Maybe we can just put this within quotes because JavaScript is going to send us really a string. Sorry, I mean text, not a string. It's going to send us text, just a single text, a sequence of characters. And then after the call, we're going to have this foo and bar. This is going to be the data space inside cell. So I think this would be a good summary of where we can start. So actually these have to be alphabetically sorted here. So that's why I'm putting A, B, C within the hash. And so yeah, so let's start with this. So we need to understand, okay, we know that there's data coming in here. We need to, let's just list the things we need to do. We need to we need to interpret the text that comes in the call. That's one. And by interpret this, I realize what it's saying, right? So once we interpret it, then we need to actually execute the call, or let's say update the data space within cell. So that would be my to-do list. If we did 1 and 2, we could already implement the set operation, let's say. And then if we, yeah, that will cover the set. And the same will go for a get, right? If you get a get operation, you first parse it, so to speak. You interpret it, you realize, okay, this is a get, and this is the message that I'm getting. And then based on that, I'm going to go to the data space and retrieve that value. There's no sort of authentication right now. This is completely open. The authentication can only come later. So how do we proceed? It's it's tough to start from scratch. It's harder than I thought. If you're being bored, you should probably skip to episode 8 or something, because this is gonna take a while. So one idea I had is that, how do you look at this text that comes in? So that I have two problems basically. Let's just list my problems. One is like taking text one character at a time, let's say. We need to do this at some point. We need to take the text one character at a time, and from there build chunks, which are normally called tokens. Actually, let's split this. Let's say problems 1. We have problem 1 is parse the call. So let's just parse the call, and parse the call also has two problems inside, which is one is split the text into, at least let's say, words. Normally they're called tokens. And then the second one is the rest of the parsing. Once you have the words, the sequence actually are going to mean something, but you start with these units. So this is normally called tokenizing, and this is parsing proper. So that's problem 1. The second problem would be actually execute the call. Actually, that's not even the problem. The problem is like define the internal representation of data. So how is this data inside cell going to live? I know it can be represented with text. Like, for example, what I'm writing, pretty much all of this that I wrote, actually all of it is valid for data that I'm putting right here. So if all of this is valid for data, does it mean that the actual data in cell is going to be expressed as text that we have to read every single time onto some memory area and then execute it from there? So that's what has me a bit stumped, to define internal representation of data. I know that at some point, when I want to build something that is persistent and performant, I will implement cell inside a database. Believe it or not, that's my plan. Like, I want to implement a version of cell that can run inside Postgres, another one that can run inside Redis. And I know that in that case, we're going to leverage the data structures of each of these databases to actually store the information. But until we get to that point, we need to come up with a first initial representation of the data. And this is an interesting problem, to say the least. So I'm thinking in terms of text. What if we have some text, and every time that a call comes in, let's say we bring that text to life, we interpret the call, we take the text that exists, and we produce something new out of it. So it would be like every single time, whenever there's a call, the system gets, so to speak, resurrected or just brought to life, and a change happens, and then we send a response in return. Because in the end, let's not forget about our basic model, right? Which is this one. This is the equation, the main equation, which is you have this, you have the add the call. destination. A call is destination message equals response. We should not forget this. This is basically pillar 3, the central pillar of TODIS. So I don't see where the internal representation fits here. It kind of doesn't fit anywhere. And when I was thinking about this more loosely a few days ago, I was just thinking, sure, we're going to implement cell within JavaScript. So the data in cell is just going to be loaded up in the memory heap of JavaScript, no problem. But now I'm actually not really seeing it that way. And I really want to explore, uncomfortable as it is, and probably awkward if you're watching this, I want to explore how would it be not to have a representation of the cell data objects that is completely opaque to cell itself. Which I think means that if I don't go that way, and if I really want to make itself similar, I have to understand at every single point that in the end, all that I am doing is calls to JavaScript. Cell, if cell is implemented in JavaScript, it's just going to be calls to JavaScript. So what would those calls be? Maybe we could actually not start from the bottom and more just start from the middle, saying, okay, let's say I had a few cell words that actually would do, sorry, not words, calls. Words is a fourth term, the fourth programming language. We have a few calls that are implemented. How would that be? How would I do how would I parse things? So it's a good question. So let's just give it a shot. Let's say that the problem of parsing is solved somehow, and I get a call, right? And the call is already structured as fourdata. So assume the call is structured as fourdata already. So where do we put this call? Because this call has to be somewhere. Everything has to be represented in the data space, even if it's transient. If it's transient, what you can do is you can remove it afterwards. But it has to, while it happens, it has to be somewhere. So a way to do it would be to have a section of the system that says, let's just think that the system only processes one call at a time, which is not a bad assumption at this stage. So we could have something like a current call, right? Something like that. So we could have part of the data space. I feel we're starting to get somewhere here, very slowly. We have something like current call, and then we have the whole thing. We could have, for example, set full bar, and we will have to have a response here, right? And the response would be, we could just basically return the actual value that we just set. But then again, y bar is the value. Maybe it's also full. Or we could be an okay. What should it be? I think at its core, what I care about is that it's everything's fine. So I would just put an okay. To be honest, I would rather have an okay than the whole thing or one value out of many. Because let's say you have something like this. What do I put here? Do I put, if I return the value, do I put this? Do I put this? And if you put everything, if you send a 5 megabyte object, you're going to get back a 5 megabyte object. That's not realistic or practical at all. Like, what I do care when I'm setting things is an acknowledgement that things actually worked. So what I'm expecting is this okay. So we can actually think, and I like this, I like the way this is going. You could think of a current call as something that is completely represented in in the data space, we're going to override it, right? If you make another call, then this is going to be overwritten. But for now, current call is one place in the data space. So if we go to our little holy book here, where am I? Yes. So pillar 2, I mean, it's everything's for data. That already I think is established. It's starting to feel even natural to me, even when I'm writing notes. Single data space basically means all the data is in the data space. So the call that you're processing, even when you're processing it, has to be somewhere. This is interesting. Like the systems that I work with normally don't have this property. You there's a data space maybe for the stuff that you store, and then what you got when you actually store it. Okay, so a way to put it would be like, normally if you want to put something in the data space, you have to explicitly do so, whereas here everything is already there in the data space. You cannot have data even traveling around and not be in the data space itself. So that's interesting. I'm trying not to get past my bedtime, but so I want the acknowledgement, and the call is reified, or actually reify is not a good word to make a thing out of something. No, it's just, it's here, it's represented here. So something comes in from JavaScript, somehow it gets parsed, and then I actually have the call here, and then it gets expanded, executed, and then I get the response. And it's all under current call. So if I was interfacing with this in JavaScript, I could be responsible for setting this thing here, and then I could be able to read whatever came out of here. And let's say now at t, time t, at t plus 1, you'd say get foo, and you would get bar. And we could even do this. Okay, this is starting to get us somewhere, I feel. If you actually get sorry, if you try to get foo before setting it, you're gonna get an empty string, empty text. Then when you set it, you get an acknowledgement. We're not going to have any errors for now, but then of course we'll add them, and then when you get it foo after setting it, you will get bar. And current call should always be, let's say, the same. This is just how it's expressed at different moments in time. So actually I don't like this, that the names are different, so we need to remove this. I definitely need an editor. We'll get there soonish. For now it's all really painfully manual, but we can do just 1, 2, 3, like this. And I think we're starting to get a feel for what it would be, right? I'm still like not forgetting about that we need to parse the call, and then we need to define its internal representation, but at least we're starting to express the two things we want right now to begin, which are set and get at a basic level. We want those two, and we are already expressing it as a call, and the call is somewhere, it exists. So I already learned that today. That feels relatively new to me, because I never implemented something quite like this. So I'm gonna call it quits here. Sorry to bail so early, but tomorrow we'll have a longer episode, and we're just gonna continue right where we left off. Thank you for watching.